Okay, so let's go on to example 2 on the back. And this is really hard to see probably, so I'm going to zoom in a little bit for each one of these problems. So for example 2, we have to evaluate each one of these logarithms without a calculator. And to do that, the best thing to do is to rewrite it in exponential form first. Remember that logarithms of any base is going to equal an exponent. So what we're looking for is the exponents that go on each one of these bases. Let me zoom in for this one, 2a. So over here, I'm just going to say I don't know what the exponent is. I'll call it x. But I know that this base 2, when I raise it to this unknown exponent, is going to give me 8. And just seeing it sometimes in exponential form, that's why it's helpful to write it in exponential form first. Because just seeing it in exponential form, you can kind of see that the exponent is 3, because 2 cubed would give us 8. So log base 2 of 8 is really equal to 3. I called it x, but you can just say log base 2 of x. Log base 2 of 8 equals 3. So again, 2 to some unknown exponent, I'll call it x, is equal to 1/4 for this example. So let's write it in exponential form. 2 to what exponent gives me 1/4? Well, 1/4 is 1 over 2 squared. So I know that the exponent here must be negative 2, because 2 to the negative 2, by definition of negative exponents, is 1 over 2 to the positive 2. So the log base 2 of 1/4 is actually equal to the exponent negative 2. For the next one, let's again write it in exponential form. 8 to what exponent is equal to the power 2? 8 to what exponent equals 2? The best thing to do here is to rewrite this 8 as a power of 2. So 2 cubed to the x equals 2. I'll put that over here. 2 cubed to the x equals 2. And 2 is just 2 to the 1. I want to rewrite this equation so I have the same base, different exponents. And this is just going to give me 2 to the 3x, power of a power. So basically I know that 3x equals 1. Same base, different exponents. These exponents must be the same. And if 3x equals 1, then x is 1/3. So this exponent x must be 1/3. And you may have already noticed that without having to go through all of this. You may have said, well, 8, I know the cubed root of 8 is 2. And the cubed root of 8 can be written, as 8 to the 1/3. So 8 to the 1/3 would give me 2. Let's have you do the you-try problems on your own. You can pause the video. I might even do an ed puzzle. I'm not sure how I'm going to do this, but 5 to what exponent gives me 1? Again, figure out what log base 2 of 64 is by knowing that this logarithm has to equal an exponent. And what is log base 81 of 3? Okay, so let's remind you of what you probably already know from Algebra 2, what the common logarithm is. The common logarithm actually has a base 10, but we don't put the base 10 in here. So if you see a logarithm of some number without a base shown, without that little number down here, that's understood to be 10. So log of x is going to equal y if and only if, that's what that abbreviation means, if and only if 10 to this y equals x. So remember, the base is understood to be 10. It's not written in. 10 to some exponent y is going to equal x. So let's go ahead and do these examples. What is log 10 to the 4th? Again, writing it in exponential form might help. This base is not shown, so it's understood to be 10. 10 to some unknown exponent, I don't know what it is, I'll put a question mark, is equal to 10 to the 4th. And it might become a little clear now that that exponent on that 10 must be 4. So let me zoom in. It's kind of hard to see maybe. So again, base is understood to be 10. 10 to what exponent gives me 10 to the 4th. So this exponent must be 4. So log of 10 to the 4th is just equal to the exponent 4. Again, the exponent isn't shown, so it's understood to be 10. So 10 to some unknown exponent, I'll call it x, is equal to this power 10 to the negative 2. And again, if you can see, this exponent, since the bases are the same to different exponents, this x must be negative 2. On this one, log 100, well, that equals some exponent. That's equal to the exponent that I put on 10. The base is understood to be 10. 10 to what exponent is equal to 100. And you may just know, but just looking at an exponential form, we know that 10 squared is equal to 100. So log 100 is equal to 2. And if you go to your calculator, you can actually just hit the log button. This is understood to be log base 10, log of 100, and it'll give you 2, because that means 10 to the second is equal to 100. So to do log of 0.001, now with a calculator you could just plug it in. But to do it without a calculator, the best way to do it, again, is to write it in exponential form. Base 10 to what exponent is equal to 0.001. Well, 1 decimal place is how many tenths? Oops, you can't see it. So 1 decimal place is tenths, hundredths. This is how many thousandths. So what I really have is 10 to the x equals 1, not tenth, not hundredths, but 1,000th. So I can see there that this is actually equal to 1 over 10 cubed. So again, negative exponents rule. So 10 to the negative 3 would equal 1 over 10 to the positive 3. So my exponent here is understood to be negative 3. And again, you can using the calculator, log of 0.001, that will give me, or 0.001, that will give me negative 3. Okay, we're going to do this example and these two questions when we're in class next time, so I'll leave these blank for right now. Let's just talk about what a natural logarithm is. You might remember that a natural logarithm is base E logarithm. And it doesn't look like log base E in this case. Instead of writing it this way, log base E of some number is equal to an exponent that goes on E. We don't write log base E at all. We just write natural log of E. Natural log of x is equal to y. And that's going to be true. Natural log of x is equal to y if and only if e to this exponent y is equal to x. So if we write these in exponential form, e squared is about 7.389. To write it in logarithmic form, I know that it's going to be natural log. Remember, logarithms give me exponents, so what goes over here on the other side of the equal sign is going to be the exponent 2, and the power of e is 7.389. So if you go to your calculator and do the natural log, with that's buttons right here, the natural log of 7.389, you're going to get about 2, not exactly 2 because it's estimating here, but that's very close to 2. And again, to write this in exponential form, remember to write this in logarithmic form, it's a base e, so instead of saying log base e, I'm just going to say natural log of this right here is going to give me this exponent negative 2. So the natural log of 0.1353 is equal to negative 2. And don't worry about this homework for right now. We're going to be doing this in class since you're doing the notes at home. All you have to do is watch the video, take the notes, answer the questions as we go along. All right, that's it.